Hello everyone, welcome back to the another video and on the topic heat transfer. We are almost at the end of this topic and today we are going to discuss some of the important problems in this topic. So let us begin. Okay, the first problem, I will read it out. A boiler is made up of a iron plate of 12 mm thick. Okay, now you have to read every sentence and you have to note down whatever given data is mentioned in the problem. Okay, now first data which is given is it's a 12 mm thick. Okay, fine. So 12 mm thick means what? This is the x. The value of x is given as 12 mm thick. If the temperature of the outside surface be 120 degrees centigrade, temperature of outside is given and that of the inside is 100 degrees centigrade. That means the T1 and T2 both the temperatures are they given in the problem. Calculate heat transfer per hour means you have to calculate the value of Q, mass of the water evaporate per hour, m you have to calculate, that is mass of the water evaporated per hour. Assume that the area of the heating surface is 5 meters square means A is given. Okay, A is given as 5 meters square. Take K for iron is 84 watt per meter Kelvin. K is nothing but the thermal conductivity of the iron material and latent heat of the water at the 100 degree centigrade is HFG is given, that is latent heat of the vaporization for the water is given as 2260 kilojoule per kg. Fine. So given data, see, always remember that always do have a good habit of writing a given data when you start solving the problem. Okay. So x, as I told you, that is nothing but the thickness of the plate. Okay. T1 and T2, these are the temperatures. So T1 is 393 Kelvin, T2 is 270 Kelvin. Of course, they have given in terms of the degree centigrade. So remember that you have to convert all temperatures in terms of the Kelvin. Okay. T is given as 1 hour and always remember you have to substitute time always in terms of the second. Okay, so convert 1 hour into second, that is 1 hour equal to 3600 seconds. A is given area of cross section, that is 5 meters square. K thermal conductivity 84 and latent heat of vaporization is also given. Fine. So let us begin with the problem. Okay, now this wall is given. Okay, so this temperature and this temperature at this point, temperature at this point they have mentioned. Okay, even this distance is given x, that is the thickness is also given. So what you have to calculate is you have to calculate the amount of heat transfer. Okay, so formula is Q equal to Ka T1 minus T2 into T divided by x, where x is the thickness of the slab or thickness of the wall. Okay. Okay. Now go and substitute the values. Okay. K is 84 watt per meter Kelvin. Fine. Substitute value of K. This is 84 watt. A is a 5 meter. Okay. Substitute value of T1 and T2. Okay. Substitute T1 and T2. Higher minus lower. This is small t, that is nothing but the time divided by x. X is nothing but the thickness of the slab and you have to convert thickness into the meter. Okay. So when you calculate, you will get the value as 2520 into 10 raised to 6 joule per hour. Okay. Or if you want to convert it into kilojoule, okay, how to convert? Divided by 10 raised to 3. So you will get 2520 into 10 raised to 3 kilojoule per hour. Okay. Now another thing, they ask you to calculate the value of m, that is the mass evaporated. Okay. For that the formula is m equal to Q divided by HFG. HFG is nothing but the latent heat of vaporization of the water which is given in the problem. So straight away substitute and the calculate value of m. So you will get 1115 kg. Okay. I hope this problem is clear for you. Now let us move to the next problem. I will read it out the problem. Heat is conducted through a wall. Okay. Wall is given. Okay, even this is a problem based on the wall. Okay, see, wall is given like this. Wall of a room made up of composite plate, okay, with the conduction of the 134 watt per meter Kelvin. Okay, now there are two sections in this wall. Okay, one is 134, this is 134, and other is 60 watt per meter Kelvin, and thickness is 36 mm and 42. Okay, now this thickness and this thickness, both the thicknesses are given. One is 30, another one is 42 respectively. The temperature are at outer surfaces is 96 degree centigrade and 8 degree centigrade, means temperature at this point and last point they are given, and you have to find out the temperature, intermediate temperature, that is T2, you have to find out. Okay, so go and write down the given data first. Okay, K1 is given, this is K1 is given, K2 is given, X1 X2 both are given, convert it into meter. T1 is given, okay, T3 is given. You have to calculate the intermediate temperature. Fine. So how to go further now? Okay, now when we solve the composite wall derivation, I hope you remember that we have solved it section by section, correct? First we took one wall, and then we have took the one wall, that is separately. Okay, same thing you have to apply here. Okay, apply for the first wall. Q equal to Ka into T1 minus T2. This is T1, this is T2. Okay, T1 minus T2 divided by X. X you have to take for the first wall. This is the first wall. Take X for the first wall. Substitute. K1 is given 134. Area is also not given. Okay, area is not mentioned in the problem. Keep it as it is. Fine. Next, T1, okay, 369 minus T2 divided by X. Okay, X is given as 0.036. Similarly, calculate Q2 equal to 60A T2 minus T3. Now T3 is mentioned in the problem, divided by X2. Okay. Now we know that Q1 is equals to Q2 under the steady condition. Okay. When it is not a function of temperature, it will remain constant throughout. So equate Q1 and Q2. Okay. So keep value of Q1 on one side, Q2 on one side. Okay. See that this A get cancelled. Okay. So what will remain with? Okay. You have to substitute that. You have to find out you have to make simplification of this. Okay, so 134 divided by 0.036, you will get 3722. 60 divided by 0.042, you will get 1429. Okay, now what you do? Divide this. Now you take this to this side. You will get 2.6. 369 T2 equal to T2 minus 281. Okay, next thing what you will do? You keep T2 on one side and transfer this 281 to other side. Okay, and finally you solve for the T2. Okay, I hope this problem is clear. Okay, you have to remember that you have to equate Q1 and Q2. Okay, and you have to solve for the calculating the value for T2. Okay, you go for the next problem. Fine. See, next problem is a furnace wall is made up of a brick of 200 mm thick. The inner and outer surfaces of the wall have temperatures 800 and 200 degrees centigrade. Temperatures are given. Find the heat loss. Q you have to find out. If the outside temperatures becomes the 25 degrees centigrade after the furnace wall is covered with the insulator of 100 thick, find the reduction in heat loss. Okay, fine. Now see here there are two cases. Okay, first one you have to calculate Q. Sorry. Okay, now see here, this is the wall they are given. Okay, here there are two parts. In first part you have to calculate Q for considering this wall, and in the next case they are given it is covered with the insulator. Okay, they are given it is covered with the insulator of 100 thick. Okay, this is the next case. Even next case you have to calculate Q, and finally you have to subtract both to find out what is the amount of heat which is lost when you introduce the insulator in between. Okay, fine. Okay, now what is given data? X1 is given, T1 is given 800, T2 is given 200. Okay, K of insulator given. Okay, K1, K2, everything is given in the problem. You have to just substitute it. Okay, fine. So Q equal to Ka into T1 minus T2 divided by X. Okay, so K is 4.5. Assume area equal to 1 meter square. Okay, T1 is 1073, T2 is 473, and X, that is value of thickness of the wall. Okay, thickness of the wall is 0.2. Fine. Now substitute all the parameters and calculate value of Q. Okay, fine. Now in second case what they have mentioned is it is covered with the insulator. Now we are having the two walls. Now this is the case of two walls. Okay, this is the first wall, this is the second wall, correct? And K1 for this is given, and for this also it is given, correct? So it is a case of the composite wall where more than two walls they are combined together. So calculate Q2. A T1 minus T3. Of course this is initial temperature, this is final temperature. So T1 minus T3, X1 by K1. Okay, plus X2 by K2. X1 is the thickness of first slab, X2 is the thickness of second slab. K1 is the thermal conductivity of the first, K2 is thermal conductivity of second. Fine. Substitute A is equals to 1, T1, T3, X1 is given, everything is given, correct? So substitute and find out the value. Okay, you will get in a joule, or if you divide by 1000 you will get in a kilojoule, correct? Now problem is not over yet. You have to calculate the amount of heat loss, correct? So when you subtract Q1 and Q2 you will get the amount of heat lost when you introduce the insulator in between. Okay, so this is what the amount of heat loss. Fine, I hope it is clear. Now we'll go to the next problem. A furnace wall is made up of the refractory brick of the 300 thick. The inner and outer surfaces of the wall have the temperatures 1000 and the 150 degree centigrade. Find the heat lost per square meter per hour. Okay, you have to find out value of Q. Okay, per square meter, that is area is 1 meter square they have mentioned, and per hour. Okay, per hour, this is very important. How, I will tell you afterwards. Okay, if the wall is covered with the insulating brick of 200 thick and thick, comma, the outside temperature becomes 50 degrees centigrade. Find the reduction in the heat lost. Take K as 4.5 watt per meter and 0.5 watt per meter for the refractory and the insulating brick respectively. Now this problem is similar to the problem which we discussed earlier now. Okay, so x1 is given. Okay, same x1 is given, t1 t2 both are given, correct. T is given as 1 hour. Now remember that, as I told you, when they are asked in per second, no problem. If they ask, if their time is given in hour, always you have to convert into the second. This is very important. If you keep 1 hour as it is, okay, 1, it is wrong, correct. So A is 1 meter square, because they are asked you to find heat in per square meter. Okay, T3 is given, T3 is the given, x2 is also given. Okay, 1 K2 they are also mentioned in the problem. Okay, fine. Okay, now first case. Okay, first case without insulator, correct. So q1 is, one second. Okay, fine. So this is without insulator, without introducing the insulator in between. So T1 is this, T2 is this. So calculate Q equal to, okay, Q equal to Ka T1 minus T2 into T. Now remember that when they ask you to calculate per second, at that time T is equals to 1. Okay, and if they mention it in the problem like 2 minutes, 3 minutes, then according to that you have to convert that into second, and you have to substitute value of small t, that is the time. So they are given it is 1 hour, so it will be a 3600 divided by x. X is 0.3, that is the thickness of the slab, correct. Now substitute all the parameters. Okay, calculate with the help of calculator, and use calculators carefully, that is very important. Okay, fine. Now the problem is not yet over. Okay, as according to previous problem also, okay, what we saw, they have introduced the insulator, correct. Now even in this problem, this is they have introduced here insulator of 0.2 meter thick, correct. So for that also you have to calculate now the amount of Q or heat lost. Okay, so substitute A equal to T1 minus T3, initial temperature minus final temperature, okay, into T, time of course, x1 by k1. X1 is thickness of first slab, k1 is thickness of second slab, sorry, first slab, plus x2 is the thickness of second slab, k2 is the thermal conductivity of the second slab. Okay, so A is 1 meter of course, into Q, sorry, T3, T1 is 1273, this is 1273, T2 is 323, okay, T is 3600, 0.3 that is the x1 divided by k1, 0.2 that is x2 divided by k2, okay, substitute, you will get the answer as 7.3 into 10 raised to 6 joule per meter square R, or if you want to convert it into kilojoule, you have to divide by 10 raised to 3. Okay, so at the end you have to calculate the heat loss. Okay, how to calculate heat loss now? You are having Q1, that is without insulator, you are having Q2 with insulator. Subtract both the Q1 and Q2, and you will get the amount of the heat lost upon the introducing the insulator. Okay, fine. Okay, next problem, we'll go to the next problem now. A glass window of a room have a total area of 10 meters square. Okay, see, as I told you, when you start reading the problem, see that what is data is given, and accordingly go on writing in the column given data. So A is given, I got the one parameter from the first sentence, 10 meter square, and the glass is 4 thick. Thickness is given, that is x. Okay, calculate the quantity of the heat loss, quantity of the heat that escape from the room by the conduction per second. Now per second means what? Here T is given as 1 second, that you have to remember. Per second, when the inside surfaces of the windows are at 225 degree centigrade and outside surfaces at the 10 degree centigrade, means value of T1 is given as well as the value of T2 is also given. The value of K is 0.84, that is the thermal conductivity of the glass is also given. Okay, now read the problem and as per the given problem write down the given data. So A is given, X is given, that is thickness. Okay, 4 mm is given, convert into meter, you have to multiply 4 into 10 raised to minus 3. 10 raised to minus 3 you have to multiply. Okay, T1 is given 25 degree centigrade, convert into Kelvin. Okay, add 273, it will convert it into Kelvin. T2 is also given, K, that is thermal conductivity, is also given. Okay, this is a straightforward question, only you have to do the substitution. Of course you should know the formula, that is very important. Okay, fine. So this is the formula, you know, Q equal to Ka T1 minus T2 divided by X. Okay, where K is thermal conductivity, A is the area of cross section, T1 minus T2 is the difference in temperature, and X is the thickness. Okay, everything is given, correct? Just you have to substitute, use your calculator properly, you will get the answer very quickly. Fine. Next problem we'll see. The walls of the room having the parallel layer in contact of a cement, brick and the wood, okay, of 20 mm, 300 mm and 10 mm respectively. Okay, means it is a case where you are having, now see, wait a minute, it is a case where you are having now 3 walls. Okay, one is cement. Okay, what is given? One is cement, this is cement, one is brick and one is, what is that, and one is wood. Okay, and x1, x2, x3, that is thicknesses of the every wall, it is mentioned. Okay, calculate the quantity of the heat that passes through the each meter square of wall per minute if temperature of the air in contact with the wall is 5 degree centigrade and 30 degree centigrade inside. The value of K for the cement, brick and wood are 0.294, 0.252, 0.166 watt per meter respectively. Okay. Yes. Fine. So first calculate, not calculate, first write down the given data as per the problem. Okay, T1 is given, that is the 30 degree centigrade temperature inside. T2 is also given as 5 degree centigrade. Okay, at 273, of course you have to convert it into Kelvin, correct? So find out Q equal to A into T1 minus T2 into T, that is the time, divided by x1 by k1 plus x2 by k2 plus x3 by k3. Okay, now per minute they have given, correct? See, each word you have to read it very carefully, correct, or else you will go wrong somewhere. Fine. So where this 1 minute play the very important role is when you substitute value of the small t. Okay, as I told you, you have to always substitute value of t in a second, correct? So A is given, that is 1 meter square, per meter square you have to calculate, correct? T1, T2, substitute, T is 60 second, per minute you have to calculate, so 1 minute equal to 60 second, divided by x1, k1, x2, k2, x3, k3, the all values are given, correct? Substitute. Okay, evaluate properly, you will get the answer very easily. Only thing is that in these problem you have to operate the calci very carefully. Okay, another problem we'll see. Fine. A metal pipe of external diameter of 250 mm carries the steam at a 200 degrees centigrade. The pipe is covered by a layer of 25 mm thick of an insulating material whose conductivity is 0.21 watt per meter Kelvin. If the outside surface is at the 100 degree centigrade, calculate the amount of heat lost per meter length per minute. Okay, fine. Now this is the case of cylindrical heat, conduction of heat to the cylindrical pipe. Fine. So D1 is given. I will read it. The a metal pipe has the external diameter, that is outside diameter, is given as 150 mm. Okay. R1, if you want to calculate R1, you have to divide the D1 by 2. You will get 75 mm and convert it into meter divided by 1000. Correct. T1 is given 200 degrees centigrade. What is that? A metal pipe carries the steam of 200. Okay, that is temperature of the steam is given, that is inside 200 degrees centigrade. So add 273, that is 400, 473. Value of K is 0.021 watt per meter Kelvin. Thickness of the insulating, of course, thickness of the insulating plate is also given, that is 0.025. Okay, T2 is also given, that is outside temperature 373 Kelvin. Length is 1 meter. See, length 1 meter, they are not given in the problem directly. You have to read, that is calculate the amount of heat lost per meter length. So per meter length means for every 1 meter, that's why L is 1 meter here. T is 1 minute. Here it is per minute means 1 minute. Convert into second, that is 60 seconds. Okay. Next. Okay. R, and how to calculate R2? R2 is R1 plus 0.025. Now what is the 0.025? That is the thickness. Okay, thickness of the plate. When you add a radius with the thickness, you will get outside. Okay, now what is this? Now see here, if this is the hollow cylinder, I will take this is hollow cylinder, correct? Now this is the nothing but the thickness, correct? This gap is the nothing but the thickness. So when you add this radius along with the thickness, you will get the R2. Fine. So R2 is your 0.0, how much it is? 0.01. Fine, it is all fine. Next, heat loss. Now use the formula for the heat transfer through the cylindrical pipe, that is 2 pi Lk. Of course, instead of L, I use N there. Okay, in the videos, whatever N, L, you take it as per your convenience. Okay, 2 pi Lk T1 minus T2 into T divided by 2.3 log of R2 by R1. Okay, so 2 pi Lk. Now 2 pi, of course, it is the constant. L is the length is 1 meter. K is the thermal conductivity, that is given. How much it is? 0.021. Temperatures are given, and even T is given as 1 minute. Convert it into second, that is 60 seconds divided by 2.3 log of 0.1 divided by 0.075. Okay, now see here, many of you do mistake while operating the calci. There is one side there is log and even LAN. Okay, in the first and second problem you might be use LAN there, correct? So LAN is nothing but, when you use the LAN, don't use this 2.3. when you use log, use this 2.3. okay, I am using log here, so I will use 2.3 log of 0.1, that is R2, divided by 0.075. correct? Substitute this, calculate individually. Calculate numerator first, write down the answer. Calculate denominator, write down the answer. Then you divide it and then you substitute the answer. That will be answer for the Q. Okay, I hope it is clear. We are almost at the end of this chapter. We'll see some of the problem if possible tomorrow, or else we'll start with the next unit, that is IC engine. Okay, fine, thank you.